Let's take a couple minutes now to dig in and see what's going to happen in each module of this course. So this was the overview. We're going to have 9 modules, and some models are going to appear in multiple modules, some models are going to appear in one module, some concepts are going to cover multiple modules, but in general, we're going to see a pretty cohesive presentation where we start with everything about linear classifiers and logistic regression, then everything about decision trees, and then we'll cover boosting and some advanced topics. So in particular, we're going to start with linear classifiers, and we discussed those in the first course. So, for example, in a sentiment analysis case, we have 2 words that I care about. The number of times the word awful appears in the review and the number of times the word awesome appears in the review. And the linear classifier might say that every awesome is worth 1, every awful is worth minus 1.5. And when you have a particular review, if it has, for example, like the one on the bottom has 3 awesomes and 0 awfuls, we're going to classify that as positive because its score is greater than 0, and that's true for everything below that line. And everything above the line has score less than 0, and we're going to classify those as negative points. We discussed this concept of linear classifiers in the first course. We're going to go in depth and really understand those in the first module, but then we'll extend it with something called logistic regression, which is going to allow us to not only predict +1 or -1, but assign a probability to every data point. So for example, the points in bright green are very likely to be positive. The points in bright fuchsia very likely to be negative, but the white band in between are areas where I'm less certain, so it's 50-50 probability. We're going to be able to predict those probabilities, and that's going to really change how your classifiers are going to get used. Now that we've defined the idea of a linear classifier in logistic regression, in the second module, we're going to figure out how to learn the parameters, the coefficients of these classifiers from data. So we define the notion of likelihood, which measures how well a line is classifying this data. And for different values of the coefficients, we're going to have different lines or different classifiers, and we're going to use gradient ascent to find the best possible classifier, in a similar way to what we did in linear regression in the previous course. Overfitting can be a really significant thing in classification. So here I'm plotting the classification error in the y-axis as we make models more and more complex. And as you know, the training error will go to 0 as you make those models more complex, but the true error will go down and eventually go up as we overfit. So in classification, the way we're going to experience that is our decision boundaries will start very simple, like a line separating positives and negatives. Then maybe it will become a curve or parabola that fits the data pretty well. But as we make the model too complex, we end up with this crazy decision boundaries. And eventually the last one here, you see that's really fitting the data way too well in a really kind of unbelievable way. So we'll see these amazing visualizations, and we'll address this issue by introducing regularization in a very similar way that we did with linear regression in the previous course. And that will be the focus of the third module. In the fourth module, we're going to explore a whole new kind of classifier called a decision tree. Decision trees are extremely useful in practice. They're simple, easy to understand, and can fit data really well, providing nonlinear features for the data. So here's an example where I'm trying to predict whether a loan you might take in the bank is going to be a good loan, safe, or is going to be a risky loan. So you might walk into the bank, and the bank person might ask you, what's your credit history like? Have you been really good? Have you paid your previous loans? If you have, then that loan is likely to be safe, likely to be a good loan. If your credit history has been okay, fair, then it depends. If it's a short loan, then I'm worried, but if it's a long loan, then eventually you'll pay it off. Now, if your credit history is bad, don't worry, not everything is bad. Maybe you'll ask about your income. If your income is high and you're asking for a long-term loan, then maybe it's okay to make a loan. But if your credit history is bad and income is low, then don't even ask me for it. So that's what a decision tree can capture, this really elaborate but very explainable cuts over the data. In Module 5, we're going to see that overfitting is not just a bad problem in logistic regression, but it's also a bad problem in decision trees. So here, as you make those trees deeper and deeper and deeper, those decision boundaries can get very, very complicated and you really overfit. So we're going to have to do something about it. And what we're going to do is use a fundamental concept called Occam's razor, where you try to find the simplest explanation for your data. And this concept goes back way before Occam, who was around the 13th century. It goes back to Pythagoras and Aristotle. And those folks said the simplest explanation is often the best one. So we're going to take these really complex deep trees and find simple ones that give you better performance and less prone to overfitting.